All right, this is Chapter 8, Topic 2, Factoring Out the Greatest Common Factor. So it is the opposite of multiplying out using the distributive property. So we're basically undoing the distributive property. But to jog your memory, we'll do a couple examples of multiplying. So if we're multiplying x times x minus 8, we have to remember to distribute to both terms. X times x gives me x squared, and x times negative 8 gives me negative 8x. So if we were to go ahead and factor that, we're doing just the opposite. We look for the GCF of our polynomial. What do they have in common? X squared and negative 8x, well, if we look at the coefficients 1 and 8, there's no GCF there, but they both have an x, so we can pull out that x. Then we ask ourselves, what do we need to multiply x by to get x squared? X times x is x squared. Then we ask ourselves, what do we need to multiply x by to get negative 8x? We multiply it by negative 8. So we're basically undoing the distributive property. If we look at the second example, we have 4h times 3h minus 5. So if I go ahead and distribute that, I get 12h squared. And then 4h times negative 5 is negative 20h. So once again, we're going to go back and we're going to factor what we just multiplied out. So 12h squared and negative 20h. First, we start with the coefficients. What is the greatest common factor of 12 and 20? The biggest number that they're both divisible by is 4. Then we look at our h's. We can only pull out what both of them have. So they each have at least one h. So that's our GCF. Now we look and see what we need to multiply our GCF by to get the original. 4 times what is 12? 3. And h times what is h squared? H. Now we have a subtraction sign. 4 times what is 20? 5. And we already have an h, so we don't need to multiply it again. Let's try it for a third time. So when we distribute that out, we have to distribute 3 times. So we have 2m squared times 2m squared. 2 times 2 is 4. M squared times m squared is m to the 4th. 2m squared times 3m. 2 times 3 is positive 6. And m squared times m is m to the 3rd. Remember, when we multiply, we add our exponents. Then we have 2m squared times negative 5. 2 times negative 5 is negative 10, and we have an m squared. So now we're going to backwards distribute, aka factoring. So we look and see, we have 4, 6, and 10. What is the greatest common factor of those three? Well, I know that they're all divisible by 2, and that is the greatest common factor of the coefficients. Then I see, how many m's can I take out? I go 4, 3, 2, so I can only take out the least number. So I have m to the 2nd power that I can take out. That is my GCF. Now I need to see, what can I multiply 2 by to get 4? 2. How about m squared to get m to the 4th? M squared. We have a plus sign. 2 times what is 6? 3. M squared times what is m to the 3rd? M. Then the last term, we look and see 2 times what is negative 10? Negative 5. And we already have m squared, so we don't need to add any more variables to that. Alright, so now we're at the next slide at the bottom of this page. So we're going to be factoring. Remember that we can always multiply back out to check your work. So something that I have done in the past is I set up a little box or a grid. There's 2 terms, so I need 2 boxes in there, and I'll put 5a squared and negative 15 in each. So what we're going to look at is we're going to see what the GCF is. So first we have a 5 and a negative 15. What is the greatest common factor of 5 and 15? 5. Now when we look at the variables, we got an a squared and then we don't have an a, so we cannot take out anything more. So now what we write on the top is what we need to multiply by to get what's in the box. So I have 5 times what is 5a squared? A squared. 5 times what is negative 15? Negative 3. So I write it as 5 times a squared minus 3. So that's another way you can look at it. It's a little more organized. So I'm going to do that one more time and then go back to how we did it before. So in this second example, once again, we only need 2 boxes because there's only 2 terms. We have 10q and negative 25q squared. So let's see, what is the GCF? First, look at the coefficient. 10 and negative 25. They are both divisible by 5, and that is the biggest number they are both divisible by. But when I look at my variables this time, I have q and q squared. Remember, I can only take out the least number, so that's just one of the q's. 5 times what is 10? 2. And I have a q here and a q here, so I don't need to multiply it by anything. I have a subtraction sign. 5 times what is 25? 5. Q times what is q squared? Q. So when I factor, I have 5q, whatever's on the left, times in parentheses what's on the top, 2 minus 5q. This last one, we can do it like we did on the last page. So we have a 4, a positive 16, and a positive 12. What is the GCF of those 3 numbers? Well, they're all divisible by 4, and I can't divide them by a higher number because I have a 4 here. So the coefficient GCF is 4. Now I look at my first variable. I have an a squared, an a, and one more a. So the least number of a's in each term is what I can pull out, so just a. Now last I look at my b's. I have a b squared, a b, and then I don't have anything there, so that is the end of my GCF. I cannot pull out something that is not there. So now I look at what I need to multiply by to get the original. So let's clean this up a little bit. We have 4a times what is 4a squared b squared? Well, I already have 4's. A times what is a squared? A. I do not have a b squared, so I also need to multiply by that. I have a plus sign in between. Now we look at our second term. 4 times what is 16? 4. I have an a and an a, so I don't need to do any more a's, but I have a b here, so I need to include that b. And last but not least, we can look at that last term. 4 times what is 12? Positive 3. I have an a, and I have an a, and that's it. There's no b's to worry about. So that is the correct factorization of that trinomial. So go ahead and do the U-tries, and that will conclude your homework for tonight.